So please welcome Claire Dorman from Tubi, Robert Raver from AWS, and Rudra Roy Chowdhury, also from Tubi. Team, over to you.
Thanks, Steve. Hey, everyone. My name's Robert Raver. I'm a specialist solutions architect with AWS and our media and entertainment business unit. I focus on media supply chain and archive. I'm our tech lead for that across the world. Part of that is metadata management. So a lot of my time is focused on how customers like Tubi can use metadata and reduce manual overhead and processes to be able to automate this.
Hi, everyone. My name is Rudra. I am a product manager at Tubi, and I focus on leading products and initiatives around AI and automation, using which we can scale content platforms and Tubi's content delivery pipeline. Thank you.
Hi, I'm Claire. I'm a machine learning engineering manager at Tubi. My team focuses on using AI, including Gen AI, as well as traditional AI for content understanding, search, and personalization. My background is in astrophysics, and since then, I've been working in both media and transportation in the machine learning space for about 10 years. And I'm really excited to be back in media at Tubi.
Cool. Thanks, Claire. So thanks for the intro, Steve. Great introduction. But Claire, why don't you give us a little bit more of a background on who Tubi is, what you do?
Sure. So Tubi is a free ad-supported video streaming platform. You can find it anywhere you find your other video streaming apps. And as you already heard, Tubi has a very large scale. We have the largest catalog of movies and TV programs in the U.S., and we also have the largest audience watching ad-supported video on demand services. So that means that machine learning is a perfect tool to use to provide recommendations and personalization on almost every customer-facing surface. And we've also started using machine learning at scale for internal customer-facing tools, such as Rosetta Stone, which we're going to talk about today.
Well, thanks. So just curious, really quick, show of hands, how many people deal with metadata, work with it? Awesome. Cool. So you're in the right place then. So, Rudra, why don't you rewind us and talk a little bit about how Tubi handled metadata and the processes before Rosetta Stone?
Sure. So traditionally, Tubi has handled metadata using a very labor-intensive and manual process. The process is very robust, no doubt, but at the same time, it's very time-consuming because there's a lot of human expertise and human effort that's always going into that pipeline. And that's exactly where we believe that we definitely want to build a robust system, but at the same time, we'd like to automate as much as possible. And that would really help Tubi further to handle the large amount of titles that we have. And that was exactly, where we thought that generative AI could play a very important role in making that happen. And that's exactly how Rosetta Stone came to life.
Thanks. So I think anybody that deals with content acquisition, distribution, media titles in general deals with metadata in one way or another. What you're talking about, with a manual overhead and processes, I think a lot of people could resonate with that. What were some of the key problems that, came out of that and having to deal with that?
Yeah. So, Rosetta Stone mainly deals with identification of IDs, title IDs. Now, as you might know already that, title IDs, for example, IMDb ID or Gracenote ID, these are very critical metadata for titles. And these metadata helps us to, use leverage our titles and also do a bunch of different use cases. Now, the key problem that we had was that for 40% of the titles that is ingested every week at Tubi, we did not get any title ID. And even for the remaining 60%, for which there were some title ID that were provided by our partners, the confidence level of accuracy was not too high, which meant that maybe someone will go in and see that, there's some ID there, but we don't know for certain if that ID is correct or not, which again means that a human expert need to get in, do the research manually, and then ensure if the ID is correct or not. And just to give you an idea of, in terms of scale, how much work this means, typically every week on average, Tubi is ingesting 350 new titles. So if you just think in terms of doing this activity for 350 titles every week, that's a huge amount of labor. And, that's why we thought that there should be definitely a way to kind of, make life a little bit easy by curbing this insane amount of manual labor. And that's exactly where, we decided to work on Rosetta Stone.
So not only do you see a lot of human labor and effort into this, but, that's also error prone too, right? So what was some of the impacts into the Tubi platform that this caused?
So there are a couple of main issues that happened because of, having this problem around not having the correct ID or not having an ID at all. So one major problem was that whenever there will not be an ID available, it became difficult for teams like machine learning, and Claire will speak more on this later, because machine learning team is responsible for channelizing all these different titles that we have on Tubi on the different parts of Tubi. And then ID is one of the critical elements that's used by the machine learning team. And when we didn't have the ID, then it became very difficult for us to make sure that the title is available on all parts of Tubi. That was a major concern. And the other problem was really about, like I touched a little bit before as well, being able to figure out these IDs like through the manual process, that is a very challenging task. I mean, like a lot of times when, like it's not a very straightforward way. So people are time and again trying these different avenues to find out manually what are these IDs for these different titles. And it just simply, didn't make any sense for us to continue doing it that way, given the scale at which Tubi operates.
Thanks for that. So you have the, metadata, you have a lot of manual processes, right? A lot of time spent on this, a lot of time with potentially even errors coming out of it, but also you have internal, lines of business and users that are impacted, and even the external ones. What were, some of the key other, lines of business within Tubi that would be impacted by this or have to deal with kind of the, outcomes of this, as well as, clear some of the external ones too?
So, like one issue that would happen from external viewer perspective would definitely be Tubi not being able to, recommend titles to the right users because of not having correct metadata. Another impact would also be like, if viewers see like inaccurate metadata on Tubi, then they would get frustrated. And we have got actually so many complaints of viewer complaints through our customer support tickets where they have, voiced their opinion that this was terribly wrong, or, this kind of frustrated me when I was watching Tubi, and we definitely never want that to happen. And yeah, I mean, like those were the main, the main items that we thought we definitely need to figure out a solution for, and also figure out a solution that is scalable in the long run. And that's how we built Rosetta Stone.
Cool. Claire, anything to add to that?
Yeah, so as Rudra mentioned, we really, really want to avoid these visible user-facing metadata mismatches. So on the machine learning team, this often resulted in building fewer and less rich products than we would want to. So as a machine learning engineer, usually the first thing that you do when building a new model is construct your training set. So take all of the content available in the library and join it to all of the metadata that you want to use as features in your model. And without this unified content management system, what would happen when you do that join on IDs is that you'll end up dropping a lot of the titles in your library. So then we would have a choice to make. Do you train a model with the entire library, but very few features based on metadata, so a weaker model? Or do you train a model based on only a limited set of the catalog, but with many informative features? And the right decision here depends on the product that you're building, but we would like to not have to make that choice and to be able to build a both wide and deep model for every user-facing feature. So machine learning is very motivated to have a unified ID space on which to join all of the great data that we're getting from our partners.
Thanks. So when we were talking before, Claire, one of the things that really intrigued me was about your culture of engineering and machine learning, even before LLMs came about, right?
Yeah.
Could you explain or elaborate a little bit more on the culture and how this came about to be looking at Rosetta Stone?
Sure. So Tubi, I would say, is a mid-sized company now, but about 15% of our engineers are machine learning specialists. And that's a pretty high ratio. I'm very grateful that Tubi invested in machine learning very early in its history. And one of the data products that we've been building for the last 6 years is what we call an embedding menagerie. So an embedding is a vector, it's a list of numbers that represents some concept about a title. So the most common embeddings are collaborative filtering embeddings. It's a vector that describes the interaction history between a title and all of the users who have watched it. But you can also have other embeddings. Word-to-vec or doc-to-vec embeddings are a way to summarize in numerical form the description, the content of a title. And you can have any number of other embeddings describing the genre distribution, the video, the frames, anything about a title. And so over the past 6 years, Tubi has built up well over a dozen different families of embeddings that describe all of the different dimensions of our huge catalog. And almost every one of the 100 models that we have in production uses many embeddings as features in those machine learning models. So when I say that Tubi has the culture and technology to do what's needed to build Rosetta Stone, I mean that we already have the knowledge and infrastructure to develop, deploy, and use embeddings in all of our systems. And as you'll see in a minute, embeddings are the key to the Rosetta Stone content management solution.
Thanks. So let's get into Rosetta Stone. How does that work?
Cool. Here it is. So before we get into how Rosetta Stone works, I want to give a huge shout out to the people who built Rosetta Stone who could not be here today. So I'm representing two of the engineers on our team, Yuanbo and John, who designed and built the engineering solution to Rosetta Stone. And then I also want to give a huge shout out to Sean, Scott, and Max for their work on tech ops and content metadata to ensure that we're building something that is usable and to use the eventual Rosetta Stone solution. So huge thanks to all of these guys. So how does Rosetta Stone work? I'll start with one more aside on embeddings. So I just talked a lot about embeddings, but one of the really cool things about embeddings is it's an output of large language models. Okay, so we normally think about LLMs as having a text prompt as input and another text response as output. But a secondary, or I would actually say primary output of large language models is that they can also output an embedding that represents either that input or that output. That's a native part of how these models are built. So for Rosetta Stone, we're going to be taking advantage of this ability to use LLMs to convert any piece of text into a numerical embedding that we can then perform any sorts of computations on. So having said that, Rosetta Stone works in 2 stages. The first stage is to build a database that includes all of the content in the content universe. And this should be indexed by and use metadata from some large metadata library. And then the second stage is every time Tubi gets a new title or a new piece of metadata, we need to find the closest match in the database, read off the ID, and assign it to this new incoming piece of data. So then the key is, how do we build the database? And how do we perform this match? So we have one more slide here. Here we go. Self-explanatory. No. So what we do is to build the database for every title in the content universe, we'll gather many different combinations of the available metadata. So the combinations displayed here are the title of the piece of content, the title plus the year plus the director, etc. So all of these are strings in English or whatever language the title comes in, and we pass that through a large language model to get an embedding that describes that combination of metadata. So we end up with a bunch of embeddings describing each title, and we insert that set of embeddings into the database. If you do this for every title, you get a very long database. So that's one step. Second step is every time a new piece of content or metadata comes into Tubi, we'll do the same exercise with any available metadata that's attached to it. So we would construct whatever subset of all of these combinations we can, extract some embeddings using large language model, and then find the closest match in the database using an approximate nearest neighbors search. And then read off the ID and assign it to the new piece of content.
Cool. Okay, so I'm going to try to repeat what you just said, only a lot in layman's terms. So part of prepping for NAB is that, unfortunately, I didn't have a lot of time to do anything other than prep for NAB. And whether I'd like to admit it or not, personally, I would want to try this myself and see how it works. So you take a large data set, like IMDb, right? And you create a bunch of embeddings from that as your base, right? And then as you get titles coming in with metadata, you're creating embeddings from that, and then doing a similarity comparison between that and your original or your base data set that you have.
That's exactly it.
Okay.
100%.
I'm glad I could say that, actually. So I can imagine a lot of problems coming up, going through that. So, but if I were to do this, what are some of the biggest problems you encountered or I should be watching out for?
So one of the big problems, there's two big problems, but they have the same solution. One is that you're going to find matches that aren't necessarily real matches. And the second is the same problem that you end up with any model-based solution, which is that there's an accuracy and cost trade-off. And every problem has its own optimal balance between accuracy and cost. For this problem, we want 100% accuracy. We would much rather have metadata with no ID than metadata mapped to the wrong title that'll be showing up for users with a clear, like labeling a family show as horror and gore. We do not want that happening. So we want very high accuracy, and at the same time, we don't want wasted computational cost. So we address these problems using 3 steps. The first step is to cut down on the computational cost, and we did that by reducing the dimensionality of the embeddings. That means taking these vectors that are over 1,000 entries long and sampling them to be much, much shorter so that there's fewer operations when we're doing the lookup for the best match in that database. So this decreases cost. It also decreases accuracy. So in the lookup in the database, instead of retrieving just the very best match, we'll retrieve many matches that might be good matches. And we defined a confidence score to apply to every candidate match and retrieve only the items with the highest confidence score. Then the third step is to make sure that these are the correct matches by having humans take a look at the candidate matches and verify them before the IDs are swapped.
Awesome, thanks. So you've gone through the Rosetta Stone, created it, been implemented, and it's been going for a little bit. If you go back to what we were talking about, Rudra, at the beginning, some of those issues with manual processes, overhead, errors, what have you seen after Rosetta Stone, right? How has that benefited Tubi?
Yeah, I'd love to talk about that because the impact has been insane for Tubi. So since we had implemented Rosetta Stone in practice, with 95% plus success rate, Rosetta Stone has been able to consistently identify the right IDs for our titles, which did not have any original ID provided by our partners. And when, we calculated like how this translates to in terms of the operational efficiency. So this, approximately saves like close to 40 hours per week for the content metadata team. And that has been like, so crazily helpful for Tubi because there are a lot of other areas. And this was really, what we thought in the beginning that We want to automate this part because we felt that this is something that can be taken up largely by a machine, whereas there are a lot of other important areas within the content metadata pipeline where we need human expertise, right? Which is not so easy to be, just asking a machine to do it for us. So we wanted to automate this part so that at the same time could be leveraged by our content metadata experts to address like some of the other critical areas, for example, like, tagging genres and things around that. And yeah, it has been massively successful.
It's good to hear. So now that you've conquered the issue with metadata management, almost as hard as solving world hunger. But what if you look at AIML and generative AI LLMs? What are some the other use cases you could think of, or the future that you think Tubi is going to be using that for?
Yeah. So one of the things that when we worked on Rosetta Stone, and then we kind of realized that it's hugely successful what we tried to do, we immediately thought about what are some of the other areas in our content delivery pipeline where we can use LLMs and generative AI. So the content delivery pipeline consists of different individual steps, and there are different kind of activities that's going on, which are like moderated and led by different teams in that pipeline. So we immediately thought one was that, okay, how do we scale Rosetta Stone itself, and how do you utilize a very similar concept to address some of the other use cases which also exist in our content delivery pipeline? And added to that, we also thought that might not be exactly Rosetta Stone, but let's explore other use cases which could also be handled using generative AI. So that is something that's in process, but we are definitely, exploring a lot of other use cases where we can potentially leverage generative AI.
Thanks for that. So, Steve, don't know how we're doing on time, but if we have some time, we'd welcome any questions that anybody would have.
Absolutely. We've got about 5 minutes left, so if anyone has a question, we've got a couple of questions.
Ooh.
Hi. Hello. Hi.
Really close.
Very close. Very close. Very close. How do you train the model? You mentioned that you have somebody that's viewing the responses that are coming back in your third step. Are you doing anything upstream to actually make it more accurate initially?
Yeah, that's a good question. So right now, the suggested matches coming out of the nearest neighbors search have a very high approval rate by our human approvers. So it hasn't been really high priority to feed that back in to the search system. But we definitely can, as we collect enough false positives, we would want to feed that back in, probably into, either the search algorithm or the confidence metric. The confidence metric works fine, but it is relatively simple, and we could incorporate more information in there.
I think there was a question over here as well. All right. Popular question there.
We have another one from her.
Another one. Could cover your question too.
I'm sorry, we missed the very beginning. Are you using just an LLM, or did you put a large vector database at the back end that you guys are actually specializing?
Yeah, there's a vector database at the back end.
Which one? Is it a open source vector database, or did you build your own?
It's an open source one.
Thank you.
Yeah.
All right. Any more questions? That's all. I've got a quick question for you. We've got a bit of time. So we all love it when projects like this go well. They rarely do. So what mistakes have you made along the road, and what have you learned from those challenges?
So I think, Steve, one of the initial things that we figured out, and I think I'll say we figured out very quickly, which was that generative AI and LLMs, like this has unlimited opportunities if we think in a way, right? There are so many different things that we can do, and especially for a video streaming platform like Tubi, there were ample number of use cases where we initially thought that, okay, this is something that we can do with AI. This is something that we can also do with AI, right? And there is always a possibility where, you can sort of get dragged away in different areas eventually probably not culminating into any solution at all. And we understood that very quickly, and we realized that, like it might seem very attractive, but we don't want to give in to everything at the same time. So we really try to identify what are the low-hanging fruits, what are the opportunities that will have massive impact on the business, and at the same time, it will be something that is feasible within a realistic time frame, right? This is like Rosetta Stone, and a couple of other things we have done using generative AI. All these came into place, I would say, within 6 months or so, right, Claire? From ideation to rollout. So that was something that we learned very early, that, there's a lot of distractions that you will get, but try to figure out, what really makes sense, that will help us drive our business, and that will actually help us, to solve real problems that Tubi and our customers have.
Absolutely. We've got time for another question.
Sorry. So given that comment of the change that's going on, first of all, did you build your own large language model, or are you using an open source style model?
We're using somebody else's.
Okay.
Yes.
And given the changes that are going on, are you doing anything that will take into effect that, the next guy may be better? How do you potentially transition from one LLM to another as the industry continues to evolve, or especially as you're seeing the multimodal activities occur, like, the 12 guys here, the 12
labs.
Thank you. Yeah, 12 labs. Thank you. Guys here that are doing video, multimodal video and audio, kind of larger LLMs technologies.
Yeah, that's a good one. So I think it varies by project how we want to approach this. For many of our projects, we'll have parallel kind of production and R&D tracks, where a key goal of the R&D tracks is to try out the latest architectures, the latest solutions especially for projects that we're struggling with. I'll call them older versions of LLMs, but they may be only a couple months old. For projects where we already have things in production using an LLM and it's meeting all of the requirements for that production application, we're not always in a huge hurry to get the latest and greatest and swap it in. We do want to do that eventually, but it may not be as important and as impactful as, iterating on an actual business problem that we're seeing, or building something else that didn't work with an older LLM because it needs more capacity. Really vague answer.
All right. I think we've got time for just one more question.
First of all, good job. This has been great.
Thanks for coming.
You're welcome. So as you truncate your vectors in order to lower compute costs, you're obviously going to increase your fuzzy matches exponentially. As you have that large increase and you're basically stack ranking on your composite score number that you're coming up with for trust value, what happens to that content that doesn't meet the bar of that composite score? And does that just directly become a pointed email to your content acquisition team, or does that become throwaway content?
So a couple points here. One, the truncation, we don't quite just truncate, and so we're able to decrease the dimensionality by a factor of almost 100 at a loss of only like a few percentage points of accuracy. So it's not as bad as it might seem. However, your point is absolutely correct. And so there's a couple different cases that come up here. One is for a given piece of metadata where we're searching the database and we find, if we find something that is a high probability of match, then it doesn't matter that there were a lot of others that didn't meet that. It's still something we can use. We can assign an ID and it can move forward through the process. The other case is where you don't find a match, and it is true that in those cases it's a lost cause for now. However, we've been able to find the right kind of tolerance of fuzzy matching so that usually, as far as we can tell, when we don't find a match, there isn't a match, or there's a match that just doesn't have enough information for any model to find it. Yeah.
Okay, fantastic. Claire, Rudra, Robert, thank you very much.